Hello, let's see how we can dissect a sphere or a spherical surface into two equal pieces in Fusion 360. Our goal is to take a sphere or a hollow sphere and figure out a way to slice it into two pieces so that they can snap into each other like a baseball. So the main idea is to use what we know about spheres and cubes in Fusion 360 or any other 3D design environment, right? So here's what we are trying to design. This is 1/2 piece of the spherical surface. We need two of these to make a hollow ball. Let's change the visual style and see, take a look at the big picture. Visual style, wireframe, so that's what we have. Let me enable the cube. There's the cube. The cube and the sphere we are going to use, they have the same dimensions, and that is to say the diameter of the sphere and the dimension of the cube are the same. So we have an opportunity to play with both the sphere and the cube. So we want to sketch something like this on one face of the cube, like a U curve, and which we'll use to split the sphere. All right, and it's a very interesting project for me, and I think it's useful for K-12 students and other educators to learn about the art of 3D design with the help of a little bit mathematics. All right, and let me close this project and start a new one. And let's change our visual style to shaded. All right. Since we know we are going to design a sphere and a cube, let's go ahead and define two parameters. The first one, let's call it big diameter, which is the diameter of the sphere and also the dimension of the cube. How about 50? All right. Since we are thinking about a hollow sphere, we have a shell, right? And let's just define the thickness. How about sphere thickness? Or you can call it anything. It's just the shell, the thickness of the shell. Let's use 4 millimeters at this moment. So now we have two parameters defined, and we can use them to design our sphere and cube. All right, let's go ahead and create our first big sphere. You can put it anywhere. Let's put it here. It's going to ask us for the diameter. You can press enter for 50 or type big diameter. There you go. So okay, now we have our first sphere, and we need another smaller one within it to create a hollow sphere. So let's go ahead and create another one. Sphere, put it somewhere else. How about here? For the diameter, we need to think about it, since we are including some thickness for the hollow sphere, and so the diameter of this smaller one should be, I think, is the big diameter minus 2 times the thickness, right? Choose the thickness. Does that make sense? Okay, press enter, and if you like, you can change its color or go back to the wire mode. Alright, next let's change the color just to make things easier talk about. Alright, let's give red color to the smaller one, give blue color to the big one. Alright, now we need to align these two things together. So let's go to modify and choose align. Let's pick the center of the big one and align it with the center of the smaller one. So now we have two spheres aligned with each other, and it's kind of hard to see now. You can go to the wire mode to see what's going on inside. So we have two spheres there, right? Makes sense? Alright, let's go back to the shaded mode. We want to do a subtraction, and in Fusion 360 we go to modify and choose combine. We are going to choose the big sphere, and then we're going to choose another one, the smaller one, as the tool body. We're going to do a cut. Alright, we can see it. I'm not absolutely sure the cut has been made. Let's change the visual style and see what's going on there. Perhaps it's not been made. Do we have a combine here? Yeah, I think so. I think the cut has been made. So now we have a hollow sphere. And alright, next we need to create a box or a cube. And as a reference, let's go to box, and you can choose any plane, XY plane. Okay, doesn't matter where you place the cube. Later on, we can align them. Okay, so of course you can define this dimension. You can type big diameter. Oh, big diameter. Press enter. Another big diameter. Press enter. So we have those two dimensions defined. Let's go up. Let's create a new body. So the height of this box should also be the big diameter. Does that make sense? So okay. So now we have a cube, and that we are going to use to sketch our U curve. Alright, next we need to align these two things. If you like, you can give it a color if you want to. Alright, so let's give it a color. How about a little bit yellowish? That looks great. Alright, next we want to align these two things, a cube and a sphere. Hopefully it's hollow now, and its core has been taken out. Go to modify, align. Kind of hard to find the center of the cube if it has one. But you know, with the sphere we can always pick the center, and then we'll do maybe multiple alignments. So how about that? So now the center is aligned with the center of the top face of the cube. That looks good. Next, let's just move the sphere down a little bit, so that the sphere and the cube and they are aligned at the center. All right. So let's move this thing down. Have a front view. How much? Well, and right now it's negative 25, and if you want to use the parameters we defined, it should be negative big diameter divided by 2, right? That's half the diameter. Okay, I think that's what we need. All right, we now have the sphere right within the cube. Okay, because the symmetry of the sphere, it really doesn't matter which face of the cube we use. We are going to choose the top face to sketch something on it. Right? So we have 6 faces here. We can sketch on either one of these. All right, let's go ahead and sketch our curve. We essentially wanted to sketch a circle here, so that should be big enough so that if you would sketch another one somewhere else on a surface that's perpendicular to the top one, these two circular cuts, they are going to be tangent to each other, touch each other in space. So that's our goal. If we do a little bit of math, we are going to realize, and there's the diameter of that circle we are going to sketch is related to, in a very, very interesting way, to the diameter of the big sphere. That's actually the diameter of the big sphere divided by the square root of 2. I just use a little bit of algebra and the Pythagorean theorem to do that calculation. It's a beautiful structure. All right, let's go ahead and sketch something. Sketch on the top of the cube. All right. Sketch a circle. Go ahead and circle diameter. All right. I'm going to find the center of this face right there, and we need to type in the diameter for the circular cut. And as I said, it should be the diameter of the big sphere divided by the square root of 2. And turns out Theorem 360 allows you to use SQRT for square root of 2, and that's pretty much the same across all programming languages. Alright, so we have a what is going on? Maybe I need to press enter. Try that. Oh, I lost. Did I lose it? Let's try. Big diameter divided by square root of 2. Press enter. Okay, that's it. Alright, so we have the diameter of this sketch. You see, it's on the top of this face, the cube. Let's look at the top view here. Next, we would like to slice this circle into 2 pieces, because we only need half the circle to make the cut. If you want to, and you can sketch a similar circle here or there, maybe here. So to perform 2 circular cuts, but because of the symmetry we are dealing with, we don't really need that. And so let's go ahead. Look at the top view. All right, I would like to sketch a line, which is the diameter of this circle. Right, that's good enough. Okay, again, because of the symmetry here, it doesn't matter. Next, we want to sketch 2 lines, and one, and 2. I want these two lines to be tangent to the circle and perpendicular to this diameter. Okay, so let's use the constraints. Perpendicular. I want this to be perpendicular to the diameter there. It's already constrained that way. Great. I also want the this line to be parallel to the other. Alright, it's already constrained, so we don't have to do that. Yep. Alright, now we don't need the diameter, or don't need the this part of the circle. We can just trim it if you want to. Trim, cut this piece off, cut this piece off. Got some more in there, and that does not really matter. Now, take a close look. We have a U curve up there on one face of the cube. We are going to remember the sphere is down there. We don't really need the cube now. We can turn it off. Now we have the sphere down there. If you don't like the blue, and you can change it to any other color. Okay, let me stop the sketching. Let's go to, I like yellow here, it shows better on the screen. Alright, so now that's the most important part of this design. So sketch a U curve up there and use that to perform the split. So are we ready? Let's go. Go to modify and find split body. We are going to split the hollow sphere and using this U curve as the tool. Does that make sense? As you can see, we did our calculation. The diameter of this semicircle now is the big diameter divided by the square root of 2. So when the U curve cuts through the sphere, and we're going to have another semicircle there, and that semicircle has the same diameter as the one at the top, and it's just a consequence of spherical symmetry. Alright, okay, that's what we need. Alright, now we have two pieces. These two pieces are not exactly the same, as you can see, because of the thickness we have for the sphere. So move this half piece to the right a little bit, as you can see. They're not quite the same. Of course, if you just focus on the outer surface, they are exactly the same. We really don't need these two pieces, so we are going to hide one of them. How about that one? Okay, we're going to focus on this one. Look at the opening of this first piece. It's like smooth, and the other piece here, you have a kind of very sharp edge there, and that's the consequence of having a thickness for the sphere. Let's turn off body 4. Now, if we were to print two pieces of this and put them together, and they are not going to go together very nicely because of the edge. So next we wanted to kind of tweak a little bit along the edge, so that we want to have a 45-degree angle there. So when two of these come together, they are going to be nice to each other. Make sense? So here's our next goal. We are going to sketch something. We need a plane. Okay, sketch a right triangle here along this curve. All right, let's go to construct and make a plane or define a plane along the path. Okay, about that one. Okay, doesn't matter where you put it. Okay, but we need such a plane to sketch a right triangle. Okay, now we have a plane defined along this perpendicular to this curve. Let's go and sketch that right triangle. Go to sketch. We are going to select this plane. Zoom in a little bit. We want to sketch a right triangle. All right. There you go. Can put it anywhere. I just put it here, and then later on I can drag it into place. Well, does it work? How about that? All right, we have a right triangle. You can certainly constrain the angles. D for dimensions. I want this angle to be 45 degrees. That's okay. Now I'm going to move this triangle into position. M. Move this curve here. Align the hypotenuse of this triangle with that corner. Alright, that's good enough. Okay. So now we have sketched a right triangle. We are going to a profile. We are going to move this triangle around the curve and make that cut. The edge, we need that. It's like a fillet, but not quite. All right, let's stop the sketching and go to create. We want to move this thing around the path, and that can be done using the sweep tool we have here. All right, that sweep. We're going to perform a cut. Okay, where's the profile? That triangle. And where's the path? And the path should be this one. Can you see it? All right. This is really a pretty picture, right? I think that's what we need. So click OK. All right. I think we got what we wanted. Make sense? We have a half piece of the sphere in terms of the surface, of course. If you make a copy of this, and you can snap them together, just for the fun of it. Let's do it. I want to select this whole piece. Go to select the body, select this guy. All right, and I'm going to do copy and paste. Good, that's a copy. Makes sense. All right, okay. Give it another color, just for the fun of it. For these two to come together, of course, you can use the align tool, but I'm going to rotate one of them. 90 degrees with that. I'm going to rotate along the other dimension. I think it should be 180 degrees, right? 180. Okay. All right, that's it. And Well, they are aligned. Let's take a front view. So let's make them come together. See what happens. All right, makes sense. The grids are confusing now. Let's turn it off. All right, as you can see, we have successfully split a sphere into two pieces. Move this apart so you can see what's going on inside. All right, I hope that I've explained basic ideas behind this project. Thank you for watching.